So the problem is to find the integral between all this jazz right here. And I originally had spent like 50 minutes on this problem because I was confused on how to get rid of the top if u is going to be this. So we can't really have this at the bottom because there's no way to get like a 1 out of that. So the u for the substitution would be y plus 1, negative y to the cube plus 1, or it could be the other way around. I just wrote it like that. And then now we need to find the derivative of u as compared to y in this case. So we would get negative 3y squared, and then throw the differential on the other side and get rid of the minus 3. So we would have negative 1/3 du is equal to y squared dy. And this is what confused me, is like, if we have a y squared, how do we get rid of the y to the 5th? And you don't actually. You try to substitute this u value in for that. So if we plug that into the integral as du, then we would have y to the 3rd to the du. Underneath would be u to the 3/2. And we still got our y third. But since y third is part of the u, we can rewrite this y in terms of u. So we already have this equation up here. And so I'm just going to try to get y third, y to the 3rd. So we would have u minus 1 divided by negative 1 is equal to y cubed. So I will just rewrite that as this. Is equal to y cubed. So now we can plug just u in, and we can actually take the derivative, not the derivative, the antiderivative. Minus 1 divided by u to the 3/2 du. Terrible u, but hopefully you get the idea. And so now we can split up the we can split up the integral, because we would have you can't really take an anti-power rule of this. So we can split up the integral into oh wait, I forgot the minus 1/3 part. There we go. We can rewrite this as by splitting up the integral and taking the 1/3 out of u divided by u to the 3/2 minus the integral of 1 divided by u to the 3/2. And oh my gosh, that was a terrible parenthesis. And evaluating this, which we can do by having by simplifying further. I'm not going to write the entire thing. I'm just going to simplify this one part first. We would have u to the minus 1/2, because this is to the 1, and when you divide exponents you subtract, so you would have minus 1/2 minus just u to the minus 3/2. And remember, there are integral things in front of this, but I'm not writing them out. And there's also a 1/3. Actually, I'll just write everything out. Integral integral and parentheses. Now you can actually evaluate the integrals, which would be u to the 1/2 divided by, so you would divide by 1/2 after that, which means you get 2, minus raised to the 1, which would be u to the minus 1/2, and so you get a minus 2 in front, which means that you would get 1/3 times yay, 2 that no, it is not a u minus plus 1 over 2 over the square root. Why do I keep writing 2? Square root of u, and then you would distribute the 3 through it. So you would get 2 of u divided by 3 plus 2 divided by 3 square root of u. Then after you do that, you can create a common denominator by multiplying this by square root of u over square root of u, which will just create 2u 3 square root of u plus 2 square root of u and plus 3 square root of u, which you can further simplify into 2 times, and if we go back up, remember u is negative y cubed plus 1, so we can go 2 1 minus y cubed plus 2 all over 3 root of 1 minus y cubed. And this can be further simplified from this by distributing the 2. So I'm just going to do the numerator over here quickly. You can distribute the 2 to 2 minus 2y cubed, which would be plus 2, which would be 4 minus 2y cubed. And now you can factor out a minus 2 if you want, or just a 2, but I'm going to do minus 2. So you then factor out a minus 2 to get a y cubed minus 2 in the numerator. So your final expression would be negative 2 y cubed minus 2 all over 3 to the square root. I should probably center that more. 3 to the square root of 1 minus y cubed plus c, because it's an indefinite integral, which means you don't evaluate it, you just find the equation. Hopefully this helped you out if you had a similar problem and were stuck like me on the u's not canceling out in the beginning. And thanks for watching.